Right now, something is quietly developing in the Pacific Ocean that most people have no idea about. And while the news cycle is dominated by oil prices, geopolitical tensions, and market movements, a climate pattern is forming thousands of kilometers away from India that could have serious consequences for hundreds of millions of people in this country. Not because of politics, not because of a war, but because of the weather, and more specifically, because of how deeply India's economy is still connected to the rain. Now you're watching Strategic Dynamics Edge, the channel that brings you the deeper economic and geopolitical analysis that doesn't always make the front page. If you're new here, subscribe right now and turn on notifications, because this is exactly the kind of content we produce every week. And if this adds value to your thinking today, hit the like button. It genuinely helps this channel reach more people who need to hear this. Before we get into what's happening in the Pacific, I need to give you some context about India that a lot of urban, educated Indians tend to overlook. India is the 5th largest economy in the world. We have over 130 unicorn startups. We have a growing tech sector and a booming services industry. But underneath all of that, agriculture still employs approximately 43% of India's total workforce, according to available labor data. That is not a marginal figure. That is the lived reality of hundreds of millions of people whose income, savings, and family stability all depend on a single seasonal event, the monsoon. Every year by June, a wall of moisture rises from the Indian Ocean and sweeps across the subcontinent for 4 months. According to agricultural data, this monsoon season accounts for roughly 80% of India's annual water requirement. It grows Punjab's wheat, Maharashtra's cotton, and Assam's tea. And for an estimated 600 million people connected to the agricultural economy, the monsoon is not just weather, it is the foundation of their financial year. Now here is something that most people don't fully appreciate. India's monsoon is not a standalone system. It doesn't simply happen because India's land heats up in summer. It is connected to a much larger global atmospheric engine. And one of the most important components of that engine sits roughly 12,000 kilometers away in the Pacific Ocean. And according to forecasts from several climate agencies in early 2026, that component is under significant stress. Scientists call the developing pattern El Nino. And the forecast being discussed this year suggests that the conditions forming in the Pacific could develop into what researchers describe as a strong to potentially severe El Nino event, one that multiple climate agencies are monitoring very closely. The India Meteorological Department has already issued an early forecast suggesting that rainfall in 2026 may fall below normal. And historically, strong El Nino years have been associated with significant disruption to India's monsoon patterns, agricultural output, and rural economy. To understand why, you need to understand a very simple concept that underlies all of atmospheric science. And once you grasp it, every climate story you ever read will make far more sense. Hot air is light, so it rises. When it rises, it leaves behind an empty space. Scientists call this a low-pressure zone. Cool air is heavy and dense. That becomes a high-pressure zone. And wind always flows from areas of high pressure toward areas of low pressure. That's the entire rule. Now apply it to India in summer. The land heats up dramatically. 40 degrees in the Thar Desert, 45 degrees on the Deccan Plateau. This creates a large low-pressure zone over the subcontinent. Meanwhile, the Indian Ocean remains cooler at around 28 to 30 degrees, creating a high-pressure zone over the water. The cool, moist ocean air rushes toward India's low pressure, picks up water along the way, and deposits it across the country as monsoon rainfall. This is India's first monsoon engine. But there is a second engine, and this one is in the Pacific Ocean near Indonesia. In a normal year, powerful winds called trade winds blow from east to west across the Pacific. They start near the coast of Peru and Ecuador and push warm surface water westward, where it piles up near Indonesia and northern Australia. This creates a large pool of warm water near Indonesia, which generates its own low-pressure zone. That zone acts like a second vacuum, pulling additional moisture from the Indian Ocean toward India and strengthening the monsoon further. So India's rainfall is powered by 2 interconnected pressure systems working together. When both function normally, India gets consistent, well-distributed rainfall. When the second system is disrupted, the effects are felt across the subcontinent. This is precisely what El Nino does. When the trade winds weaken, which happens periodically due to natural atmospheric cycles, the warm water pool near Indonesia doesn't stay in place. It slides back eastward across the Pacific toward South America. And when it moves, the second low-pressure zone over the western Pacific disappears. But it doesn't just disappear. In many cases, the pressure pattern actually reverses. Where there used to be a system pulling moisture toward India, there is now a system pushing it away. The monsoon doesn't stop completely, but it arrives later than normal, weaker than normal, and unevenly distributed across the country. And according to historical data compiled by meteorologists, this matters enormously. The Asian Development Bank has estimated that a 1% decline in rainfall is associated with approximately a 0.16% decline in India's GDP. If IMD's current forecast of roughly 8% below normal rainfall holds, that is a meaningful economic impact, felt most acutely not in urban India, but in the villages and farm districts where the majority of India's workforce still lives. Historical records show that El Niño years have consistently been difficult for India's agricultural economy. In 1972, a strong El Niño year, India's GDP growth turned negative. In 1987, the country faced wheat import pressures. In 2002, growth slowed significantly. In 2015, an El Niño year, food inflation rose sharply and agricultural distress was widespread and well documented. According to meteorological analysis, approximately 10 of the 12 worst droughts in India since 1950 have been associated with El Niño conditions in the Pacific. These are not coincidences. They reflect a consistent, well-understood mechanism connecting Pacific Ocean temperatures to Indian rainfall patterns, and in the historical record, there are much older and more severe examples of what strong El Niño events combined with poor agricultural infrastructure can produce. The Great Famine of 1876, studied extensively by climate historians, is associated with a severe El Niño event that disrupted monsoon rainfall across Asia. What historians emphasize about that period, however, is not just the climate event itself. It is the combination of climate stress and the near-complete absence of modern food storage, irrigation infrastructure, or welfare systems that made the human consequences so devastating. That context matters, and we will come back to it. Now, here is why this conversation is particularly important for 2026 specifically. India is not entering this potential El Niño year from a position of economic stability. Global oil prices remain elevated due to ongoing tensions in West Asia. Wholesale inflation has risen sharply in recent months. Vegetable oil prices are surging. The cost of essentials is already elevated for ordinary Indian households. If agricultural income takes a hit this year on top of these existing pressures, the combined effect on rural consumption, FMCG demand, and ultimately GDP growth could be significant. Rural India contributes approximately 37% of total FMCG spending in the country. When farmers earn less, factories slow down. When demand in villages drops, the economic effects ripple across the entire supply chain. This is not speculation. This is the documented pattern from every major El Niño event in modern Indian economic history. So the central question this raises is India prepared? And the honest answer is that India in 2026 is far better positioned than it was even 2 decades ago, and incomparably better than it was in 1876. As of April 1st, 2026, the Food Corporation of India was holding approximately 604 lakh tons of wheat and rice in buffer stocks, nearly 3 times the mandatory minimum buffer of 210 lakh tons. This is genuinely significant. It means that even if this year's harvest is below normal, India has a substantial cushion to manage food availability and price stability. The government has also put in place various supply chain management and price stabilization measures. And India's agricultural forecasting and early warning systems are far more sophisticated than at any point in our history. So the humanitarian worst-case scenario, the kind of catastrophe that occurred in the 19th century, is not a realistic risk in 2026. Let's be clear about that. But a more modest and still very real risk is on the table. Higher food prices, lower farm incomes, reduced rural spending, and slower GDP growth. And that risk falls disproportionately on the farmers and agricultural workers, who are already the most economically vulnerable. The structural issue remains what it has always been. Approximately 44% of India's farmland has no irrigation infrastructure whatsoever. No canals, no tube wells, no drip systems. These farms depend entirely on rainfall. And that is the root vulnerability, not El Niño. El Niño is a trigger. The root cause is that nearly half our agricultural land is still completely dependent on the mercy of a seasonal weather pattern. The solution to that is drip irrigation at scale, solar-powered micro-irrigation for small and marginal farmers, and sustained public investment in water infrastructure. Not just announcements, but actual deployment. And beyond agriculture, India needs to accelerate the structural shift that every developed economy has already made, gradually moving its workforce from subsistence farming into manufacturing, skilled trades, and services. South Korea did this in a single generation. India has the opportunity and the capability to do the same. We simply cannot allow a temperature anomaly in a distant ocean to determine the economic fate of 600 million people year after year. The El Niño story is ultimately not a climate story. It is a policy story. It is a story about choices India has made and choices India has not yet made, about the irrigation systems we have not built, the workforce transitions we have delayed, and the structural dependencies we have allowed to persist. The IMD forecasts and the climate agency warnings being issued in early 2026 are valuable precisely because they give us time. Time to prepare buffer distribution systems, time to subsidize farmers proactively, and time to have the policy conversations that matter. India has genuinely improved its crisis preparedness in meaningful ways. The food buffer alone is a real achievement. But awareness of the underlying structural vulnerability is the first step toward fixing it. And that is exactly why conversations like this one matter. A quick note before we close. Everything discussed in this video is based on IMD seasonal forecasts, publicly available agricultural and economic research, and historical climate records. El Nino forecasting involves significant uncertainty. Climate models are improving, but not perfectly precise, and conditions can change between now and the peak of the monsoon season. The intent here is informed awareness, not alarm. If you want to follow updates, IMD publishes regular seasonal outlooks that are publicly accessible and worth bookmarking.